I've already introduced the crew, but here we are again suiting up. There's Bob. These suits are uncomfortable but necessary, and we're used to them now. We have some terrific folks that maintain them for us and make sure they fit us right, and we've gotten pretty used to wearing them. You just saw Rich, there's Jim, and of course Guy. And as we walk out, I'll hand it over to Bob to let him talk a little bit about the ascent evolution.
Yeah, for those that can't read that very well, that said beat Army. Unfortunately, all my efforts to cheer the midshipmen on came to no avail as the Navy ended up losing the game. We got out on the pad and we ended up sitting for about an hour and a half after our initial launch time due to ice on the vehicle, so we had to wait for the sun to come up and warm things up a little bit. And then it was a little bit of a race to see whether the sun could melt everything off before the clouds moved in and prevented us from going. But fortunately, everything came together all at once, and we were able to get off on launch day. This was my second flight aboard Discovery, and I don't care how many times you've flown on a space shuttle. It's a pretty spectacular experience when those solids light off and you start going uphill. Here you can see our rollover to a 57-degree inclination insertion. Discovery, as Dave mentioned, it was just a fantastic vehicle, considering that it was the first flight after major mod and all the work that was done on it. It was like brand new, and it performed exceptionally well. As you all know, the solids burn for about 2 minutes, then they separate. Here's a nice shot of the turn to flying up the East Coast. Once we get off the solids, it's another 6.5 minutes to our orbital velocity, 17,500 miles an hour. And then once we get to MECO, it was time to set up shop on orbit and get DOD-1 deployed, and I'll let Guy talk a little.
This is a shot of inside the cockpit as we got ready for on-orbit activities. Once we got on orbit, the initial activity was to prepare the deployment of DOD-1, which went very successfully. And then once we got DOD-1 deployed, then we set up for our secondary experiments and prepared to do that for the next 6 days.
Each day we change out some lithium hydroxide canisters on board the shuttle to keep our atmosphere clean, and as I was preparing to do that on our first morning, I found out we had a stowaway on board. As you may have heard, we had a training team that was called the Bad Dog Training Team, and we became, because of that, the dog crew, each of us having dog names and having a lot of fun with that during our training. And we thought we'd left that behind when we launched, but sure enough, we came up with this stowaway who had the unfortunate fate of having the worst dog name of all, and that was Dog Breath. But we did have some fun with that while we were in space as well. Made for a few light moments. And Dog Breath watched over us throughout our flight and made sure that we did a good job.
We're going to walk you through some of the secondaries that we did on the orbit. Here you see some pictures of Dave Walker and myself operating the BLAST experiment, which is the Battlefield Laser Acquisition Sensor Test. You see in the overhead window there, Dave's holding the optical head assembly, which is supposed to sense a ground-based low-power laser which has a data stream embedded in it. The purpose of the experiment was to, 1, acquire the laser, and 2, interpret the data stream. We had some success in that. It was originally forecast that we could just point it out the overhead windows. However, our orbiter attitude for other secondary experiments, which had a higher priority, prevented us from essentially crossing in the perpendicular of the ground-based laser. So we ended up having to point it, and we did have some success in that.
Here you see a guy working with a computer that was part of the Hercules experiment. Hercules was a handheld electronic still camera that was attached to an inertial measurement unit. It allowed us to combine the ability to take photographs out the window with geolocating very precisely where those places were. We did alignments with the inertial measurement unit on stars, and then we took pictures of points on the ground and were able to locate them, they expected within 1 to 2 nautical miles. They don't have the data back yet, but the preliminary look at them looks like they're very close to what they expected within several nautical miles of the actual site. This gives us a really great increase in capability with knowing what we're taking pictures of from space. And this is the camera and the inertial measurement unit that I'm holding after just taking a photograph of a point on the ground.
This is a shot of a volcano that we took a picture of as we flew around the Earth. We were up about 160 miles when we flew by this crater, which is formerly in the Soviet Union. This is also a shot of the coast of the Soviet Union.
This is the glow cryo heat pipe experiment. This is the glow portion of it. This is the extreme UV spectrometer. A little further aft on the bulkhead are the two cryo heat pipes in a canister, one built by TRW, the other by Hughes, that used liquid oxygen as the transport medium. The glow portion of the experiment, the UV spectrometer here, was taking a look at the interaction of the orbiter with the extreme thin atmosphere in low Earth orbit. In doing so, it measured the spectrum as well as the density of the interaction. And then we also did water dumps. Here you can see a water dump out the side port. Looks like a snowstorm in space, but the spectrometer was also taking a look at how this debris interacts with the environment around the orbiter. And additionally, some RCS jet firings. Here you can see some primary jet firings that it was also looking at.
One of the few night passes.
We had a really nice feature on board the vehicle, and that was a PC and a modem, and you can see me operating that PC. We were able to send personal messages down to our families, and the families were able to send personal messages up to us each day, as well as the local news. And we could print off these messages. We could bring the messages up on the screen or print them out on a printer, and you can see me printing out a personal message that was sent up by one of the family members. This was really a nice feature that we had to keep us up to date as to what was going on while we were on orbit.
This is one of the many medical DSOs that we participated in. This one is taking retinal photography. I'm using a fundus camera to shoot a picture of Rich's retina. Then by measuring the dilation of the blood vessels, taking a look at fluid shift within the body. Along with that, we also numbed his eye here and used a tonopen, or a tonometer, to measure the pressure within inside his eye. This was done the first couple of days in orbit and then at the end of the mission. And they're looking at how fluid shift within the body affects space motion sickness, as well as how we adapt to a microgravity environment.
You can tell who the rookie was on the flight.
No choice.
Another experiment that we flew was microcapsules in space. This was looking at pharmaceutical making microcapsules or microspheres, 50-micron spheres, using ampicillin as the drug and a biodegradable polymer to encase it. We haven't got the total results back on the experiment yet, but hopes are that they can produce these microspheres that would be like time-released capsules for antibiotics.
This is another medical type experiment called the visual function tester. It was used to try to measure the changes in our visual performance in a space flight environment. We looked in the box and looked at things that we'll show you here and tried to measure the changes in our contrast threshold, the directional perception, and pattern perceptions. So Dave and I would look into this each day for about 20 minutes and do the test and try to see the differences down here in space.
What you're seeing here is views of the fluid acquisition and resupply experiment, FAIR. One of the most dynamic experiments we had on orbit, and truly for one of the special ones for a shuttle mission. Its purpose is to develop new methods of transferring Earth-storable liquids on orbit, specifically for propellant tank design. When you have to start resupplying the space station with shuttle, you're going to have to try to get rid of all the fluid that you're bringing up there because weight to orbit is extremely expensive. And this is developing new methods and new procedures to transfer those propellants and other liquids that may need. What you see here is the expulsion of a fluid. It's being drawn in through those two vane devices, essentially very minute screens, and the bubbles are coalescing around the screen. Another of the tests that we did on orbit were seeing the fluid motion. At this time we're not draining the tank, but we're watching the motion of the fluid inside it during primary jet firings, and you can see that the motion's rather dramatic. And one of the critical events is that you do not want gas to be ingested in the jet that you may be firing when you're expulsing fluid out of the propellant tank. So this is part of the test results are to determine, one, better methods of expulsing the tank, and two, of refilling it. And we did 8 separate tests, 4 of them with vented fills and 4 of them with evacuated fills. A rather successful test.
Here's Bob using a relatively novel method of mounting our rowing machine. A large part of what we do on each space flight is to determine better ways to live and work in space, and we have determined that exercise is real important in giving you both physical and mental well-being, and of course counteracting the deconditioning that goes on even from the first day you get into space. Dogs are a problem whether you're working out on the Earth or in space. As you saw, Bob was doing pretty much aerobic exercises there. This rowing machine is extremely versatile. We're real fond of it. I'm doing more the strength exercises, demonstrating them. We, in fact, worked out an average of 30 minutes a day each on the machine in space from the 4th day through the end of the flight, and found it very helpful. It really makes you feel good. Because of the lack of gravity, it's a lot more versatile than an ordinary rowing machine. As you can see, in addition to the actual rowing motion, you can do squats and presses, standing and sitting, and curls. It really makes for an excellent all-around exercise device, and we hope to have something similar to it, although probably a little more complex, on Space Station.
This is a shot of a sunrise and on our orbit, or sunset. And we had a unique flight in the sense that we never really had a complete sunset, and so Rich never saw a complete sunset in space. In this view, we're getting ready to come home, and the pilot and commander have already climbed into their LESs in preparation for coming home. I've climbed into my LES, and in the preparation for coming home, we were diverted 1 complete rev. So instead of landing at the Cape, we were told to land at Edwards because of weather. So we had to wave off 1 complete rev, and then Rich, shown in this shot, and then Jim later on climbed into their LESs in preparation for coming home. So this is the guys up in the cockpit getting set to ride the vehicle home from 160 nautical miles.
Here's the very end of that operation. I might mention that we did have, I think, the record cross range we've ever had in the orbiter. It made for a continuous right descending turn coming down from the north end Edwards Air Force Base. When we got there, the weather turned out to be not quite as good, at least right over the runway, as we had hoped. We wound up with a ceiling at about 4,000 feet. It didn't cause any problems in making the landing, but we do feel we've logged the first instrument approach, if you will, in the space shuttle. All the navigation devices worked just as advertised, and it was a piece of cake to fly. There's a little crosswind here, which you'll be able to see perhaps if you look carefully, and some small right wing down inputs as I get close to the ground here. Bob does a great job of keeping me straight and advising me, helping me with the approach, and getting the gear down, which is a real career limiter if you don't do it. There you see the touchdown. Because we had a crosswind that was within the limits to do so, we're going to deploy the drag chute here. The drag chute worked extremely well. The handling qualities with the drag chute were as good as we could have hoped. And even though, as you can see from the crosswind, it did tend to veer out to the left of the orbiter, it didn't cause any difficulty in the handling during the rollout, which is good news, because we're counting on this drag chute to improve our rollout margins in the future. And of course, it's an excellent device for that. Really enjoyed the landing. We were happy to be home. We'd been in the suits a long time, and we were ready to get out of them. As it turns out, we didn't get out of them quite as quickly as we might have hoped. But other than that, it was a nearly perfect flight, and we had a great time.